To solve this question, we need to treat the heights of the bounces as a geometric progression, GP, because the change in height isn't a fixed amount like subtraction, but a fixed ratio like multiplication. In the question, it states that the first bounce height is 10 feet. It also states that each bounce is 50% of the previous one. This is going to be the common ratio, r. So our variables are the first term, or the starting value of the sequence, a, is 10. The common ratio, r, is 1 over 2, or 0.5. N is the position of the bounce in the sequence. In part A, they're asking to calculate the 10th bounce, so n is 10. To find the height of the 10th bounce, we use the nth term formula, a times r to the power of n minus 1. Here, n is 10, so our exponent is 10 minus 1, which is 9. Our calculation is 10 times 1/2 to the 9th power. 1/2 to the 9th is 1 over 512. Multiplying by 10 gives us 10 over 512, which simplifies to 5 over 256 feet. So the denominator for part A is 256. Next, we need the total vertical distance from the first hit until the end of the 10th bounce. Keep in mind that for every bounce, the ball travels up and down. We will need this piece of information in a while. For part B, we are going to use the sum formula for 10 terms. So, S sub 10 equals 10 times 1 minus 0.5 to the 10th power, all over 1 minus 0.5. This is equal to 5,115 over 256. Since the ball travels up and down, as we mentioned earlier, we double this sum. So 5,115 over 256 times 2 equals 5,115 over 128. Therefore, the denominator for part B will be equal to 128. Finally, what is the maximum distance the ball can travel, no matter how many times it bounces? This requires the sum to infinity formula. So, sum to infinity equals 10 over 1 minus 0.5. This is equal to 20. Remember when we mentioned that the ball goes both up and down? This results in doubling the motion. So, 20 times 2 equals 40. Let me explain this briefly. Imagine you have a giant pizza. You eat half. Then you eat half of what's left. Then half of that. Even if you do this forever, you'll never eat more than one whole pizza. You just keep taking smaller and smaller bites. This is called a limit. Our ball does the same thing with distance. The first bounce goes up 10 feet. The next is 5 feet, then 2.5 feet, and so on. The bounces become so tiny they basically stop adding anything to their total. But remember, every time a ball goes up, it has to come down. This is why adding 20 feet of ups to 20 feet of downs will result in 40 feet total. Therefore, identifying your first term and common ratio, you can model the entire path of the ball. If you find this helpful, hit the like and subscribe buttons for more math walkthroughs. See you next time.